Okay. Hello folks, my name is Vandatan. Welcome back to the channel. I hope you're doing good, and in this video we'll start solving some DSA problems. So we are gonna follow Striver's A to Z DSA sheet, and I've already solved a couple of problems, but in this video we are gonna start from the most basic problems. Okay, so I won't be able to show you a lot of rough work and the things which I progressively look forward while basically while I'm solving problems. I won't be able to show you the rough work, but definitely I'll explain you the algorithms, and then we'll see everything accordingly. Let's try to solve problems. So right now I've already solved these many problems, but we are going to try to do a second iteration, and then after that we'll move forward. So right now the problem is to remove duplicate elements from the sorted array. So basically this is the problem. We have to remove the elements from the sorted array. Now there are multiple ways to solve this problem, and let's talk about the brute force algorithm first and how we're going to solve this problem. Let us say, for example, you have been given an array. I might have this already coded. Yeah, so you have given like a array of given size. So then basically according to this problem, what you have to do is you have to make sure that the array contains, for example, k distinct elements, and so basically till the size of k over here. So till this size, what you have to do is just a second. Okay, cool. So this you have to take the unique elements of the array, and then basically you have to sort it in the order in which you encounter it, and then rest all these positions, they don't really matter, like what you put on them. So there are multiple instances in the way you can solve this problem. So the very first brute force solution which comes into my mind is whenever I see a problem like this. So the very first brute force solution would be to brute force solution would be to use hash maps. Secondly, you can but that would require extra space. Another way you can solve this problem is using extra space, and you can store data in another array. Okay, now the third and the most optimized version would be to use two pointers. So for example, let us say like I have this I at the start, and similarly I'll have this j at the end. Okay, so let's say for example, if we have, okay, let me check if the array is from a sorted array. Okay, so if the array is sorted, so we definitely know that so we know that so if the array is sorted, so basically we know that the element, for example element I will always be smaller than I plus 1. So we can be rest assured. So okay, so we can just check if I is equals to I plus 1. So if we check this, like if I is equals to I plus 1, if it is, so we can replace I plus 1. Okay, so yeah, so we can replace I plus 1 with I, for example, so we can replace I plus 1 with j, maybe 4 is the example. Okay, and we can swap this. Okay, so this is how we're able to solve this. I mean, my algorithm seems to be like, I cannot explain you the algorithm. I am not able to explain you the algorithm. That is the whole point of it. So let's try another way by how we can solve this. We have this. So maybe like let me just take all of this and I'll push it down a little bit. Okay, right. So for example, let us say if we have a like if we have this, so if we have, for example, trying to loop in, and if we have j, if I is equals to j, what we can do, and let's say if I is equals to j, for example, then we found our, so let me just now this is where remove duplicates. Already I have marked it as revisit. So the brute force approach, so let's try the brute force approach. So we have to think of the data structure, which basically data structure that does not store duplicate elements, so that we can use hash set. So if we try to use hash set, so what we can do is, so basically hash set is a data structure which stores data multiple occurrences of data, please don't mind my spelling, multiple occurrences of data with, hash data structure, okay, data structure which stores multiple occurrences of a data only once. And that's how yeah, that is how this will work. I hope it's clear. Okay, so now let's try to use hash set for the same. And to use hash set, how we'll use hash set, that's another tricky thing. So let's just directly jump in the code, and then int so basically int k is equals to 0. So now int for example, what we can do is hash set integer set is equals to new hash set, and that's how you create a hash set. Now for we'll use for each loop. So int data nums, and what I'll do is set dot add data, or if set dot contains set dot add data. Now basically we'll Google hash set in Java. Okay, so let's try to learn from the documentation itself. Extends abstract set, and so these are the methods inherited from class Java, util abstract, from abstract collections, from add all, and all of this. Constructor detail, okay, hash set. Method details, it is let me just check. Okay, so it will be int k is equals to set dot size, and like for integer I is equals to 0, I smaller than k, I plus plus, and we can have an iterator over set, and we can like use an iterator over set, and then have the values filled in the, or updated in the array. Perfect. I just have to check whether sorry for the hiccup, guys. Yeah. Okay, so I'll have to check in a code a little bit. Okay, so the implementation we did right. The implementation was right. And k is equals to set dot size. Okay, so that's a nice way. So basically what we can do is, for integer I, or they did it even better. Okay, so what I'll do is I'll just not use this, and I'll say integer. So for integer data once again, but this time from set, and I'll say that for example I'll just keep int I is equals to 0 and nums of I plus plus. Okay, I'll do this. Nums of I plus plus is equals to data. If I do that, and if I try to return, I'll just say return k. Okay, let's try to run this code. Okay, set dot size is a method, so it will contain brackets. Accepted. And then I'll just submit the solution. So we are getting a wrong answer. Okay, so the wrong answer is -1 -3 -1 0 0 0 3 3 3. So according to this algorithm, it should add I try to submit it once again. Let me just check if okay, so it didn't pass this test case. Okay, so let's try to dissect why this code didn't work in the first place. Okay, so let's again try to dissect that. What are we doing wrong over here? Let me just check the stream status and everything. I'm also streaming on Discord as well, so that if we like get some crew or people, I will pop it out. Okay, if someone joins in, or like decides to study with us, so that will be a great plus. That will be actually good. That will be actually good. I'll minimize this. Right, perfect. Just wanna shut down. Quit the calendar. Quit Chrome. I wanna quit this hyper. I'm just gonna remove this as well. Remove doc. I'll remove this VLC. But okay, let it be. Okay, so let's try to once again dissect this, and then maybe try that why this code is not working. So for that, basically just first of all let's study what are we doing wrong, and for that I'll just quickly open lead code patterns. not lead code playground. Okay, I'll open lead code playground, and also I'll open program biz, and in this let's try to study a little bit more about how actually Java hash sets work. So hash set class of Java collections framework provided functionalities of the hash table data structure. It implements set and face. So hash set basically implements sets, which basically extends collection. So create a hash set. So create a hash. For creating hash set, we must import java.util.hash set first. Once we import the package, here is how we can create hash sets in Java, and this is how we create hash set in Java. Here we have created a hash set number. Notice the new parts of notice the part new. Here the first parameter is the capacity, and the second parameter is load factor. So the capacity of the hash set is 8, meaning it can store 8 elements, and load factor is the hash set, load factor of the hash set is 0.6, means whenever a hash set is filled by 60%, the elements are moved to a new hash table of double the size of the original hash table. Default capacity and load factor. So it is possible to create a hash set without defining its natural capacity. Let me just put this into dark mode, otherwise my eyes were burning out. So yeah, the capacity method of hash set, methods of hash set. So we have add and add all. Okay, so we have this, and to access elements of hash sets, to access elements of hash set, we can use iterator method. In order, we must import java .util.iterator. Okay, quickly let's open DSA practice. I'm gonna oh, thank God we have this in dark mode. My eyes were technically burning. Eclipse, Mount Kai. Just let me change the setting as well. Okay, I'll probably use this GitHub theme for a while now. Or maybe I'll use Eclipse. So it basically it doesn't look cool, but no worries. Okay, so let's try to work with it. So I'll just have a class main, and let's from scratch code this. So our very first would be public static void main, and inside it will be have string args. Okay, now let's create a hash set. So create a hash set. Okay, so I'll set. Okay, so to create hash set, we'll have hash set, and with basically integer, and then what we can do is we can have its name. I'll name it set equals to new hash set once again, and I'll say so basically inside this these brackets we can have two things. So here we can have the size and load balance. I guess it was named as load balance, right? we have load factor. Okay, capacity and load factor. So capacity and load factor. Perfect. If we do that, now let's add elements into the hash set. If we do that, if we add elements in our hash set, so we can have set dot add 1, set dot add 2, set dot add 3, set dot add 4, and set dot add 5. Perfect. Now let's try to print it. So sys. Okay, so we can do print set. I'll run the code and we get these values inside it. Now let us say, for example, if I have an array. Okay, so let's say if I have int an array. Okay, so inside this array, if we have, let's say for example, int arr equals to, let's say 1 2 3 4 5, yeah, similar things. So instead of doing this, I had a hunch of maybe if we can do this, set dot add all, and I can say arr. If I try to run this, so yeah, type cannot be converted to collection integer. Okay, so we cannot use this. Okay, that makes sense. Now we have to access the elements, okay, one by one. Okay, so we cannot do this. Now this was, we printed the entire array all at once. Now to access the elements of the array, elements of the set. Let me just check the stream as well. Elements of the set. Let me just check the stream as well. Elements of the set. Let me just check the stream as well. Okay, so we are technically so let's try to use iterator. Okay, so I guess insert element, we did insert element, access hash elements. Now yeah, okay, so this is a task. Okay, so let's try to dissect it once. and let's paste it over here. See, okay, so what is this? Oh yeah, so what is this? Okay, so this is iterator. So to call iterator, we have to do iterator and then of what? Integer. Then with it we can iterate numbers. So iterator, then sys out, okay, so basically if you wanna, so while so here it will be set dot iterator, and it will be iterator dot has next. Makes sense. So I have to remember a couple of things. So which is iterator dot has next. Okay, so let's try it. Okay, let's try it. Let's have iterator and integer of type integer. I'll name it the name of iterator. Okay, it3 new iterator. Okay, so while now which is numbers dot iterator. So let me just check. Okay, so yeah, it will be set dot iterate, set dot iterate. While iterator dot has next. You know, let's calculate the sum of the elements inside. So int sum is equals to 0, or int sum, and then we can say that sum plus equals to iterator dot next. I guess I'm iterator dot next, and then we can just system out our sum. If let's try to do it like this. Okay, so let me run the code. There is some error, might not been initialized, so we have to initialize the sum as well. Okay, so I initialize the sum as well. I run the code and see, it gives you the output. So 1 plus 2 plus 3 plus 4 is equals to 15. Perfect. So this is how we iterate over the hash set. Now let's learn a couple of more things. To remove elements, we do it by remove. To Okay, we can find union of sets, intersections of sets, differences of sets, and we can also find subsets. Clone contains, okay, we can use contains as well, is empty clear. Makes sense. This is how we can solve this problem. Now we know a lot about sets. Okay, so now I don't know why this code went wrong. So I'll use this array for example and code it, and then we'll see that how we are doing in this problem. Okay, so just erase everything once again. I'll print the array and I have to give out. So we need to find int k. Okay, we need to find k first of all. So now I'll create a hash set of type integer, and we'll name it set. We'll say new hash set, and I'll give it no capacity, or I once again forgot the name. What was it? It was like, I guess, load or something like that. Load maintainer, or I don't remember what it was called. Creating hash load factor. Okay, load factor hash set. Now let's add elements in set. So for integer data as of ARR, we'll say set dot add data. Okay, now let's log it data. Okay, I'll run it quickly. Oh, sorry. So the name of the variable is set. Okay, I'll clear the console first and then maybe run it. So 1 2 3, perfect. Now I'll say int k is equals to set dot size, right? I'll system dot out dot println the size as well. If I do that, we get 3, right? Now let's try to modify it. So if I say int j is equals to 0, so basically while set dot so basically we can use for each loop once again. So for integer dot set for integer data in set. So if you do this and then say j arr of j plus plus equals to data, right? And now we try to log our now we try to console log our set once again. If I run the code, okay, so I'll have to print the array. Okay, yeah, perfect. Okay, so I'll say string arr. That's how I'm gonna print it. 1 2 3 2 2 2 2 2. Perfect. Now if I take this example, take this for instance, take this test case for instance, and try to run it over here. I'm just gonna clear the console. Yeah, just gonna clear the console. So here the unique elements are -3, -1, 0 and 3. Okay, zero minus 3 3. I don't know, maybe if it is some internal glitch or something like that. Let me just go to the submissions. But is there a discussion tab? Okay, there is. So if I go to solutions, if someone has posted in Java, let's try to find if someone has. So yeah. Indicate fails. So I'm just gonna copy it. Okay, I'm just gonna copy it and I'll paste the solution over here, and I'll take the test case where my solution was failing. Submissions, and I'll take this array once again. I'll copy paste it over here. Okay, copy paste it over here. Let's see. Okay, so basically, like, it is some internal error of Java's, or maybe there is something wrong with the test case. Minus 3 3. Okay, there is something wrong in the way how hash set stores the data. Okay, no problem. I mean, we definitely know the solution, and there's optimal approach, which is 2 pointers. So the one which we were discussing before. Okay, so which we were discussing before, let's try to have a verbal approach. So in this intuition, we can think of 2 pointers, I and j. We will move I till we don't get a number arrj, which is different from arri. As we got a unique number, we will increase the pointer. And update its value by arrj. So approach is take a variable I as 0, and use a for loop for using the same variable. Use a for loop by using a variable j from 1 to length of array. If where arrj is not equals to I, increase I and update arri equals to arrj. After completion of the loop, return I plus 1. That is the size of array of unique elements. So this is something how they wanna work it up. Okay, so what my let's take my example into consideration, and then we'll try to solve all this after we have got some concrete knowledge with us. Now let's say, for example, if we have I and j, so let's say we have I is equals to 1 and j is equals to this. Let's I is equals to 0 and j is equals to this. So I'll have to find a place where I is not equals to j. Okay, so if I is not equals to j, so I have to find that. Here I is equals to j, then I'll do j plus plus, and since this is different, what I can do is I can replace I plus 1 with this. Okay, 2. Now I plus 1 with this. Okay, now we'll find j is similar over here, j is similar over here, but j is different over here. Once again, I'll take I plus 1, okay, the third value, and we'll put it over here. Perfect, makes sense. And then I'll say check if it is similar over here, perfect. And then I'll encounter a different value where I is not equals to j, and then here we will add 4, okay, at I plus 1, always adding at I plus 1, and then once again we found a now once again doing j plus plus, I is not equals to 0, I is not equals to j, I equals to j, I equals to j, I equals to j, and then we reach the end of the array. Perfect. Now let's take another example to check if our algorithm works or not. Let's say I have a array of sorted elements. Perfect. So let's take some more typical examples. Okay, so now I have I over here, and then we have j right now. So if I is equals to 1, and then so let's say if I is equals to 0, let's start from this. So I is not equals to 0, so I plus 1 equals to j. Okay, and I will move over here, and then once again, so let me just write the algorithm as well. If I equals to j, j plus plus, we will do j plus plus. If I is not equals to j, we will do I plus 1 equals to j. I hope that's clear. So once again, check if okay, so once again from scratch, let's do it once again from scratch. We have I, okay, and okay, as one more thing, we have always I is equals to I is starting from 0, and we have j is equals to I plus 1. Okay, so we have that. Now since I is at 0 and j is at I plus 1, so if I is equals to j, no, I is not equals to j, then I plus 1 equals to j. Okay, so I is over here, I plus 1 is equals to j, and also and I plus plus. We'll do that. And let me more modify it to make it easier for you. Right, now let's take another for example. Let's move forward. Okay, so if we move from this to this now, oh sorry, yeah, so we were here I plus j and then I plus plus. Okay, then once again the j will be starting from I plus 1 if they're different. Okay, so I is not equals to j, I plus 1 equals to j, and I plus 1 equals to j, which is 3, it will be equal to 3, and now we move j. Perfect. And then once again I is not equals to j, I plus 1, which is this 4, will be equals to j, which is 4, and then I plus plus. Perfect. And then we will encounter that if I is not equals to j, Okay, so once again we'll have this 5 and then this. Okay, and now we have like we will start from this. Okay, so I is equals to 0 0, right, this. So basically now we encounter that I is not equals to j, right? I is not equals to j. So what we'll do like I plus 1 equals to j, which is 6 right now, which is 6. Okay, can I color the single element? No, I cannot. Don't worry. Yeah, we so basically we'll make it 6. We made it 6. Okay, and then I plus plus, I is over here. Now let's try I is equals to 0, j plus plus, I equals to j, j plus plus, I equals to j plus plus, I equals to j. No, I is not equals to j. We will do I plus 1 equals to j, which is 7 right now, and then which is 7 right now, and then do I plus plus. Once again we'll check if I equals to j. No, I plus 1, which is this right now, will become 8, and then this, and then j plus plus. Then once again I equals to j plus plus. That is how we will get an array. Which basically is okay till here itself, which is basically like contains this, and our k would be equal to, so our k would be equal to I, which is in this case 1 2 3 4 5 6 7 8, which is 8. I hope you got the gist of this. Now let's try to submit our solution without hash set. Okay, now for example we'll have integer so let's try for integer I is equals to 0, I smaller than arr dot length I plus plus. Okay, now we have for integer j is equals to I plus 1, j is smaller than arr dot length gth and j plus plus. Now if we'll write the condition, if nums of I is equals to nums of j, we do j plus plus, else nums of I is not equals to, else if nums of I is not equals to j, so what we do, we basically check so we do nums of I plus 1 equals to nums of j break, and then we break it. No, we won't break it actually. We'll have to work a little bit more on how to write this code. Yeah. Still again, so we are teaching gold here, guys, and no one is joining us on Discord. I do have friends, but even they are not joining today. Guess it's a lonely day today. Yeah, but no problem. Let's check if anyone is online. check if the server is active today. A lot of members are online, but then no problem. Let me open my Twitter today. Long time I haven't used Twitter. Let's create a new post today. And let me add the image as well. Let me open my stream link. Perfect. Posted it. Now back to coding once again. So yeah, let me just simply try to write the code of what I visualized, a pseudo code first. So for integer I is equals to 0 smaller than arr dot length I plus plus, while j is smaller, for this j is equals to this length. Okay, so probably we won't need just a second, just a second, guys, give me a second.